Hey all you cool cats and kittens, here to talk to you about YFind. So, the year's 2020, we have self-driving cars and voice-activated directions, but we still can't seem to find our way across campus. Any freshman with a class in the LSB knows BYU is no exception to this. The problem comes from giving users directions and leaving them to interpret or misinterpret how to navigate there. And the confusion is understandable, and the cycle continues as those directions are only useful for about 4 months. The goal of our project is to not only provide directions to users, but to guide users all the way to their destination. Our project shares some work with Google Maps, Esri, and BYU's campus map. And the unique value we're trying to bring to the table is navigation assistance at the room level, route data and directions custom built for campus, and accessibility route data, which is really beneficial to campus goers with disabilities.
So how did we make all of this magic happen? So our magic stack of resources we use to implement this app includes several things. First, we utilize ArcGIS, which is a geographic software platform that's really helpful for working with maps and other geographic information. We then incorporated BYU's building, room, and map information on top of this platform to build out the map and geolocation functionality. And on top of this, we utilized a package called ARKit plus geolocation, or ARKL for short, which allowed us to use the geolocations provided by BYU and incorporate them into a guided view using augmented reality. So as far as alternatives go, Google Maps, or really any other similar mapping app, would be considered an alternative because it can route people to buildings on campus. However, these apps are limited because they only provide routing to the building itself and do not have access to room information. And you can also note that it's kind of difficult to see the buildings on the Google Maps app in this screenshot. So, as you can see from the screenshots of the YFind app, buildings are much easier to see on our map, and if you zoom in, you can also view the in-building map for better room navigation. And also, following maps on your phone can also be a little confusing, which is why our YFind app has a guided view option, which allows you to see your destination through your camera using augmented reality.
So the goal of our design was to fit each requirement for our application in a simple interface that is easy and intuitive to use. Our target user group includes students, guest speakers, EFY kids, and any other people visiting campus trying to navigate the BYU building system. So we wanted it to be easy to use for all different types of people, even those who have little technical expertise. Some of the main functionality that we wanted to include in our design was first and foremost the ability to enter or search a building and room number via search or by selection, the ability to select a building on a map and then navigate to that building, the ability to utilize the smartphone's GPS capabilities or to, for example, if you're using an iPhone or Android device, to ask for location services so we can track the user's location, the ability to navigate user to building via 2D map, or be able to show the user where they are relative to that map, and then the ability to navigate the user to a room via augmented reality so that they can essentially just pull up their camera and show where the room is relative to their location. Some of our usability requirements included having little to no setup required in order to use the application. Because BYU is integrating our app into theirs, as long as they have the BYU app, there should be no setup required. Must have minimal steps to begin the GPS AR navigation, and then an intuitive design so that all ages and all types of users can use it. So we were able to start this process by hand drawing out our flow for our app. We started this by drawing out the search for building, room, the actual map, and then we took this design and pulled it online into a mock-up where we designed each page of our flow. So the start of our flow was the search for a building, and then or the search and selection for a building, the selection of a room number, the confirmation for the destination, and then the 2D map showing where the user is in relative to their route, and then the actual route to the room number. We also have the augmented reality view with the option to switch back to the map view so that they can go back and forth depending on their preference, and then a confirmation that they've arrived at their destination. And this was extremely beneficial for us because we were able to port this design over to our storyboards, which we used to build our iOS and Android applications. In this section, I'm going to be talking about the methodology that we used to build our application. Over the semester, our group went through 2 iterations to complete our app. The goal of the first iteration was to complete our MVP. And we decided that the earliest we could get to a useful product for our users would be 2D routing without the AR feature, which we ended up taking care of in our second iteration. This would allow the user to search a building, a room, and then route to the room via a 2D map. Some of the technologies that we used to complete this iteration were Swift, the programming language to build iOS apps, Kotlin, which is used to build Android apps, and ArcGIS, which we needed for our geographical data for each room and building on campus. ArcGIS would eventually serve us with our searches, routing, and eventually our augmented reality. So the first step of our project was configuring this platform. So ArcGIS is basically just a platform where you can build map layers. A layer is a group of objects that must be drawn out and described on the platform, and then they can be distributed to you via their REST APIs. Our app consisted of 2 of these layers. The first being the building layer, which provided us with all the building data. So this is an image of the building layer on ArcGIS's platform, including the drawn out buildings and some of the data points used for each building. And then we also had a room layer for each building on campus. So this is an example of that. This is the Tanner building, and you can see all the detail that went into drawing out this floor plan layer. And this was provided to us by BYU, and we just had to integrate this into our app. So we added the building layer, the floor plan layer, and then we had to start writing the code to query these layers for the proper data and pinpoint different locations on the map. So one of the struggles that we dealt with during this process was learning how to use the Swift language, which none of us had previously worked with. And we also had to learn how to architect iOS apps properly. And luckily, with the help of a few mentors, we were able to hammer out the architecture and code needed to build out each page of our flow until we were able to reach the full functionality of 2D routing. Once we felt that we were in a good place with our 2D routing system, we wanted to take our app one step further by adding augmented reality. If you're not familiar with AR is where you can turn the area around you into a matrix where objects can be placed and interacted with through your device. So the idea of this was to open the camera on the user's device and be able to show where the room is located via a pin, just like this. So the user would be able to switch to a guided view, and then our app would take into account their location, the location of the searched location, and then be able to show them exactly the direction where they needed to go. So the way we were able to implement this was by using 2 packages provided by Apple. One of these is ARKit, which allows us to build that AR space and place objects in an AR matrix, and then Core Location, which gave us access to the user's location data. So by adding these packages together, we're able to do something really cool where we take into account the user's location, and then we say, based off of that user's location, where is the room in the AR space relative to where they are? So which direction is it based off of the user's compass? And then we were able to end up with this finished product.
The following video demos how someone would use our app So the first page a user sees is a building search where they can manually scroll through the buildings available or search them by their acronym. And the next view then lists all the available rooms within that building, and you can either scroll through them or type in a room that you want to go to. And then once you do that, a confirmation page will show up, which you can hit yes. And then the map view opens up. And as you can see, the route was generated to the room from my location. Note how the buildings also have the acronyms above them, making it easy to find the building that you want to go to. And you can see it responds well to my positioning as I'm moving. You can then switch from the map view to the guided view, which is what I'm doing now, which populates the route to the location with blue dots and then a pin over the destination itself. And as you can see, the blue dots are a little difficult to follow, but we're hoping to refine this part of the functionality once BYU finishes the routing layer for us. And as you can see, it's pretty responsive to changes in the camera, movement, etc. The next video shows augmented reality with just the destination pin, so not that unfinished blue dot route. And you can see it stays pretty well over the destination, which is the ASB room 201, pretty well despite the movement. And users can switch in between both views just to get a better idea for navigation, whether they find the map view better or if it's helpful to look through the camera to see where they're actually going in the augmented reality.
To discuss the strengths and weaknesses of our core design principles, we thought assigning a grade to each would be most effective. Ability to enter in a building or room number via search or drop-down. We'll give it an A. The searching feature is extremely clean and works exactly as designed. The user can search by a building and room to easily find the location they are going to. Ability to select a building on a map. Rather than selecting a building from the map itself, we stuck to the searching feature. After all, if you're getting directions to the building, you probably can't pick it off a map. Ability to utilize smartphone's GPS capabilities. We'll also give it an A. The location tracking is very good. When looking at the map and route in 2D, the app follows you as you spin around with your phone, allowing you to orient yourself in the direction you need to walk. Ability to navigate user to building via 2D map. We'll give this one a B. The app does a great job of quickly showing the route to a building along with a distance and time estimate. The route is correct and will get the user to the designated location. However, there is some room for improvement here in the way of fastest. There isn't any through buildings routing, which is sometimes truly the fastest way to a destination. Ability to navigate user to room via augmented reality. We have to give this one a C. The AR pinpoint that is placed over the building you are walking to is great. It gives a visual mark of where the person should be walking to help the most lost users. However, the AR dots that we wanted to appear on the ground to show the route still need improvement. We feel this is an important feature that should be improved upon in future iterations for the best functional user experience. Moving on to usability, the app must have little to no setup required in order to use it. We'll also have to give this one a C. Right now, the app is a little difficult to get installed. One must clone the Git repository and then install the app onto a phone. In future iterations through BYU, integration into the current BYU app would be most desirable. This would allow a user to simply add the maps to their BYU app, allow location access, and begin to use the navigation. Must have minimal steps to begin GPS or AR navigation. This one can get an A. User flow from start of app to getting navigation is painless. Simply search the building and room, click yes on the confirmation screen, and the map is produced. Must have intuitive design so that all ages can use it. This one will get a B. The search feature is very intuitive. It is easy to get to the 2D map. However, the AR is a little harder to understand, especially if the blue dots are on the ground. In future iterations, it would be important to eliminate this weakness by improving the overall quality of the AR, so even less technically inclined individuals could easily use the feature. Overall, we are pleased with the outcome of our project. There are a few design weaknesses that can continue to be improved in future iterations, but the product is something we can be proud of. Now Andy will talk about some of the lessons we learned.
We learned from this, we learned to make documentation a top criteria when evaluating tools to use. It may be difficult to gauge the usefulness of documentation before using it in practice, but out-of-date, poor, or even misleading documentation took considerable time away from productive development. Oftentimes the SDK documentation was outdated or lacking, and examples didn't even work with the current paradigm for Swift. Another was to make sure needed data is available before the deadline. We were told the route service that our project depended on would be ready at the start of our project, but for whatever circumstance, we never got it. Like John showed with the augmented reality points, we struggled to display meaningful direction from the basic data available. I also learned that proximity is important. The closer you are to people you are building the app for, or the people you're building the app with, or the location you base your app from, the faster you can iterate your development. We took campus for granted the first semester, and after campus closed, we lost the ability to make our development highly interactive like is shown in this clip. And going forward, we recommend leveraging the ArcGIS REST API to use ArcGIS as a data layer, rather than wrestling with the SDK. The mobile SDKs will be necessary for rendering ArcGIS specific map layers, but the ArcGIS REST API has better documentation, adoption from community, and support for important features like retrieving elevation data for points. And where the REST API is used, you could also leverage libraries with better documentation and community adoption. One example we had success with was the ARKit and Core Location. It made development for augmented reality in iOS much smoother. And finally, don't take campus for granted and stay close to your project. You never know when a global pandemic will remove access to a critical resource.